If you want to learn how to make a top-down dungeon crawler, something inspired by classics like Gauntlet and even Diablo, something that has path-finding enemies, an area of effect explosions, something that was the beginning of my own dungeon crawler game, a top-down, couch co-op, action RPG with randomly generated levels and multiple player characters, then keep watching and I'll show you how. G'day gamers, and welcome back to our top-down dungeon crawler series. In the previous episode, I showed how you can add movement and collisions to your player character. Now you'll need that project in order to follow along, so make sure you've completed that first. I'll add a link to that episode up the top if you've missed it. Now this tutorial is going to be dual drag and drop and GML. I'm going to show both codes side by side, so no matter which method you prefer, you'll be able to follow along. We'll also learn how to set up animations for our player when we're moving, and we'll set up the player's bow. Firstly though, I'm going to rearrange the groups to take advantage of Gamemaker 2.3's new group structure, which allows any resource type to be placed in any group folder. So over here on the right, I'm just going to select some things that we don't really need for this project. And we'll press delete to get rid of those. And also I'm going to change this to custom order, and that lets us sort the order any way we like. Now in the description, you'll find that I've added the resource for the sprites we want to use. So download that and extract the contents into a folder, and then you can add the resources you'll need for the project. Now these resources are part Creative Commons license and part sprites that I've created. I'll add the links to where I downloaded them in the description as well. Now being a Creative Commons 0 license, you can use them in any way you like, including my additional sprites. So I'm going to right click over here, go to create group, and let's create a player group. Now if you bring up your resources, you'll see that there are 3 player sprites. So I'm going to select all of those and just drag them in and make sure we drop them under the player. So if we go to the idle sprite, and this is when the player's not moving, the first thing I'm going to change is the collision mask over here. And this is the area that the sprite will use for collisions. So by default, it's set as automatic, which is the boundaries of the sprite. I'm just going to change it to manual and just drag it a little bit down here to make it a little bit fairer for the player. Now, the other thing we want to change is if I close that down, we have this little point here, which is the origin of the sprite. That means it's the sprite's X and Y position. Now, I want to set it down here to essentially be the middle of the player. So I'm going to set it at 16 and 24 at that point there. You can type it in directly up here if you like, or just drag it to the position. Now to ensure a smooth transition between all of our sprites, we want to have the origin at the same position. So if we close this down and go to our walk sprite, we can set this as 16 and 24 as well. For the mask of the walk sprite, it doesn't matter because we'll only be using the idle mask. It just makes transitioning easier if we just use the mask of one of the sprites. So let's set the origin for the dead as well, 16 and 24. So if we go into our objects and just grab our player, let's put our player down here as well into our player group. And let's go into our player and drag the idle sprite across for the player. Now that assigns the sprite, but we're still using the collision mask as same as sprite. And what that means is if we change sprites, then we'll use the collision mask of the new sprite. And we don't want that. We always want to use the idle sprite. It's actually much easier because it avoids a lot of collision problems. So let's go in here and make sure we change this to not this one, not same as sprite, but idle. So doing it like this ensures we use the idle mask at all times. So if we test this out now, we'll see that our player has the idle sprite. Now the problem is we always have the idle sprite. In order to swap to the walk sprite, well, we need to tell it to do that. And I also noticed that our sprite moves very fast. I'm just going to go into the create event on drag and drop and just change the walk speed to 1.5. If you're on GML, it'll already be 1.5. So in order to change the sprite, we want to know if the player is moving. And this happens in our calc movement script. So let's go there. So at the moment with our movement, we're declaring some local or temporary variables. But I want to make them instance variables. I want them to remain so that we can use them later and find out if the player was moving. So I'm going to change this to an instance variable. by removing that underscore and using the assign variable code block. And in GML, we're just removing the VAR and they'll turn blue, indicating they are instance variables. So we'll do one for hmove and we'll do the same for vmove. Now, once you've changed them there, you also need to go through the code here and make sure you change every reference of hmove and vmove to not have the underscore. Now, that underscore is what I use to indicate it's a local variable or a temporary variable. So by removing this, it just means we're now using our instance variables and they're available in other functions rather than the one they were created in. So if you're in drag and drop, just make sure you remove the temporary on these function calls for hmove and vmove because they're now instance variables. We don't want to set them as temporary anymore. So now they've been removed, I'm going to make a new script. Now, if you're in GML, you can just add a new function down the bottom instead. But for drag and drop users, we're going to add a function called anim. And this will be for our animation. Now, in order to work out if the player's moving, we need to look at hmove or vmove. And if any of those are not equal to 0, well, then the player's moving and we can use the walk sprite. But if they're both 0, then we want to use the idle sprite. So let's have a check here. And let's say that if our hmove is not equal to 0 or our vmove is not equal to 0, well, then we can set the sprite index to be our S-player walk sprite. Else, if that's not true, well, then we can set our sprite index to be our S-player idle sprite. So now if we go back to our player, we can go back to the step event and just down the bottom, after we do our calc movement, we can execute a script and we can just execute that anim script. Now also, because we've added hmove and vmove as new variables, we'll need to go into our reset variable script and define those as well. So just add 2 more variables there into that. It's our vmove and our hmove, and we're setting them to 0. So let's press play and we can test that out. So now we're in the idle animation. If we move, then we're in the walk animation. But when we walk backwards, we're still in the walk, but we're not facing the direction that we're moving. So let's go and look at how we can fix that. If we go back into our player, into the create event, let's add a new assign variable and let's assign a variable called facing and just set it to 1. And facing will be the direction we're facing, either 1 to the right or -1 to the left. Now we can use that in our calc movement script. So just where we've set our hmove, let's go and ask a question here. And let's say if hmove is not equal to 0, which means we are moving, then I want to set facing to be the value of hmove. Because hmove is going to be either 1, -1, or 0. And if it's not equal to 0, well, then it's equal to 1 because we're moving to the right, or it's equal to -1 because we're moving to the left. And using that variable, we can actually use that on our sprite to flip it because we can set the scale to 1, which is the normal way of drawing it, or -1, which flips it on its origin. So let's use that in the player. Let's add a draw event for the player. And if you're in drag and drop, you go all the way back down and there's a draw sprite transformed code block. Meanwhile, if you're in GML, you want to use the draw sprite ext. Now by default, every object has a draw event. But if you create one like we've done here, then it no longer will draw the object anymore. Instead, you have to draw it yourself manually. So by default, there is a draw self function here. And this is what it would normally look like for every instance. But we're going to overwrite that because we want to access a particular value of it and we want to change it. So we're going to use our draw sprite ext or our draw sprite transformed, depending which one you're using. And we want to draw the sprite index, the image index, which is the current frame that we're on. For our X, we're just setting it to 0 relative and our Y is 0 relative, but we're here for the scale X value or the image X scale value. And we want to set that to our facing direction because that will be a 1 or a -1 and that'll flip the sprite on its origin. Now the others are set as the default values. And once you have that in, you can press play and test that out. So now we have the player able to flip on their axis and we get a left running player and a right running player. So let's start adding something fun like a bow that they can use to shoot. So inside the sprites, there is a bow sprite. Just drag that in top of the player. And as well as that, I'm going to take the cursor and drag that in too. Now for the cursor, you want to set that to middle center. And for the bow, we want to set the origin down here at 1016. And that's where the player's hand will be, so that's where we want to rotate it. Now we can close that down and we create a new object called O_bow. And we can assign that bow sprite to that object. Now we want to create the bow when the player is created. So let's go back into the player and go to the create event. And let's add an instance here of the bow. And we can just create that at the player's X and Y. And I'm going to store the value that's returned from when you create the instance into a variable. And I'm going to call it my bow. So when this instance gets created, the ID of the bow is then stored in this my bow variable. And we can use that ID to reference the instance that we created. Now, the other thing I want to do is take the cursor and use that now as the player's default cursor. So I'm just going to assign the cursor sprite to equal our S cursor. And that'll change the default cursor into our S cursor graphic. So as well as that, we're going to call a function. And the function is window set cursor. And what that does is change the default cursor to something else. We're going to set it to none, which means we won't see the default Windows cursor in the game. So if we press run and have a look what that looks like. So we have a bow and we have our cursor working, but the bow doesn't follow the player or the bow doesn't follow the mouse cursor. So let's fix those few things. So firstly, I'm going to position the bow above the player and then make it point to the mouse when we move around the screen. So let's go back to our calc movement and down the bottom, after we've done our H move and our V move check, I'm going to assign another variable. And this time I'm creating a variable called aim_dir. And this will be the direction that we're aiming. And the direction we want is from the player to the mouse cursor. So we can use point direction to get that direction. So point direction will take in 2 points. So in this case, we're taking our X and our Y position and we're finding the direction between mouse X and mouse Y. And that is the position of the mouse. Now I've created the variable here and I haven't declared it in the create event. So let's go back to the player's create event. And let's just ensure that we declare that aim_dir variable and we'll just set it to 0. So back in our calc movement, now that we have the direction that we're aiming, we can set the bow's angle to that direction. And we can just do that by taking another assigned variable and we'll set my bow dot image angle to be aim direction. So what this is doing is looking at the instance in our myBow variable, and we're setting the image angle of it, which is the angle of the rotation of the sprite, and we're setting it to the aim direction that we just found above. So let's press play and test that out. And now we have a bow that points to the mouse cursor. But obviously we need to do some work still because it doesn't follow the player. And the other thing you'll notice is it's behind the player. We want it on top of the player. And that's controlled by the depth. So each instance has a depth variable, and that's used to determine when they get drawn. All the depth variables are placed in a list from highest to lowest, and then each instance is drawn one after the other. And what that means is the ones at the top with the high value are drawn first, and we go down the list to the ones with the lowest depth value down the bottom. But that also means that the way you view them means that the ones with the high depth value get drawn first, and everything with a lower value gets drawn on top of it. So if you want something to appear above something else, you need to have a lower depth value. So let's go over to the player and let's add an end step event. And I want to do the movement of the bow in the end step because the player's already moved. So then we want to set the bow to the position of the player. And when you have an instance that follows another instance, it's always a good idea to do the follow code in the end step so that they get the updated move position. So let's assign the bow's depth to whatever the player's depth is, -1. And that'll put it above the player. So let's run that again and have a look. And now we have a bow above the player, but it looks really odd. And the reason is because if the player's holding the bow, they're not spinning it on the axis like that. Instead, they're holding it out in front of them and moving it in a circle around them. So let's set that up. Now, in order to make the bow appear to be drawn in a circle around the player, I'm going to use length_dir X and length_dir Y. I've talked about them before in other tutorials, but basically what they will do is if you have 2 points, they'll give you the X value and the Y value to get to that point. So let's go over and assign our bow's X. So myBow.x, and I want to use our length_dir X. Now length_dir X requires a length and a direction. So I'm going to use bow distance, and I'll set that variable up in a moment. And the direction is going to be our aim direction. Now remember, this value is just the X component. We still need to add it onto the player's X in order to position the bow correctly. So make sure at the front of that you say X plus. Now we don't want to use relative because we don't want to add it on per step. This value is going to just draw this bow at that position. So we can do another one, and this is for myBow.y. And this time it's Y plus our length_dir Y between our bow distance, and the direction is our aim direction. So for bow distance, let's just go in our create event, and just here where we're setting up our bow, we'll have our bow distance, and I'm just going to set it to 11. And the reason we're doing it this way is we're going to make some changes to this later and make it appear like we're firing. So we want to have this as a value here. So let's press play and test that out. So now our bow stays with the player and it rotates at a distance away from him. Now a few more things I'd like to fix. When the bow is above his head, I would like it to go behind him. And when it's down below, I'd like it to stay in front. In order to know how to do this, I'm just going to go here and draw some text. You don't need to do this. We're going to draw our X and our Y plus 20, and I'm going to draw the aim direction. So what I wanted to show is that the orientation Gamemaker uses for its angles is 0 is to the right, and it increases as we move around in an anti-clockwise direction. So when we want the bow to be behind the player, we want it at the time when it's between 0 and 180. So any time up here is when we want the depth value to be greater than the player's depth value. And then when it's between 180 and 360, well, then it can be above the player. So the depth value needs to be less than the player's. So if we go back to our end step, we can use that and we can do a test. If I create a local variable and I'm going to call it underscore depth, and we're going to do a test. I'm going to check for what aim direction is. So aim direction being greater than 0 and aim direction being less than 180. So because we're doing a condition check, we're checking if aim direction is greater than 0 and aim direction is less than 180. So if this is true, if aim direction is greater than 0, that will return a true or a 1. That's the same thing. And if this one's true, if aim direction is less than 180, it will return a 1 as well. And when you do true and true, well, the answer is true, which means depth has a value of 1. Because true and 1 are interchangeable. False and 0 are interchangeable. So if all of this is true, it means that the bow angle is up the top, our depth is 1. And what we can do down here, instead of minusing 1, we can add the underscore depth value to the depth of the player based on this condition check. So now if we press play, we'll see that when the bow goes behind, that condition makes the depth a greater value than the player's, and it puts it behind them. But when we come down the front, that local variable depth doesn't change. It actually stays at 0, and that means it actually is an equal depth to the player. Then why does it stay above the player if they're the same depth? Well, that's because the bow was created after the player was created. And even though it's an unwritten rule, the depth values are sorted by the ID, and the player's ID was created before, so it's a value that is less than the bow's. So that's why it appears above the player, and here it goes below because of that depth change. So that looks great. Now the only thing I want to change is when we're running this way but aiming this way, the player is still pointing in the other direction. So I want to make the player always face where the cursor is. So we need to make some adjustments to our facing variable. So let's go back to our calc movement script. And this time where we're setting our facing, we're going to make some changes to this. Basically, I'm just going to delete this section. And this time I'm going to create a temporary variable called underscore facing, and we're going to use the same concept. And that is when our aim direction is less than 90. So anytime it's here, or if it's down here, and that is when it's greater than 270, because you'll see that it loops over at this point. So when our aim direction is greater than 270 or less than 90, then our facing is 1 because we're pointing to the right. Otherwise, it's -1 because we want to point to the left. So let's check for that by saying if our aim direction is less than 90 or our aim direction is greater than 270, if this is true, then facing is going to be 1. And that means that our facing is to the right. But if it's not true, facing is going to be 0. So we need to do a little check here and check for that. And we want to check if facing is equal to 0, then we'll just say that facing is actually equal to -1. Because that means it's on the left-hand side, and that means we want to have facing as -1, not as 0. So the only thing left to do is assign that underscore facing temporary variable to our actual facing variable. So let's press play and test that out. So now, no matter where we go, we're always facing the cursor. And the bow is doing the right thing in relation to the player's depth. Now this kind of control is similar to what I used for the hunter in Keepers of Pyrite. That's my top-down dungeon crawler that I'm currently working on. The hunter is one of the 4 characters you can play, and although the mage can shoot a wand, the hunter is the only class who uses a bow. If you want to see more of my game, I've been posting content on Twitter as well as over on Patreon, so if you're a member, check that out over there. These Patreons help me put out content in a quicker fashion, so thank you for their generosity. My legendary Patreons this month are Kaiser Ho, Andy K, Colin Litchfield, and Smash TRM. My epic supporters are Skydevil Palm, Salvatore Capolino, Dan Half, Edward Lyko, Paul Arla Blank, David Stylinger, Robert Churches, Joachim Froholt, and Samuel Mai. Thank you for your support, guys. I really appreciate it. If you're interested in learning more about Gamemaker, you can check out my Gamemaker 2 course over on Udemy. It's the highest rated Gamemaker 2 course on the site, so check that out if that's of interest to you. For now, we need the player to be able to shoot, which is one of the things I'll cover in the next tutorial. So thanks for joining me. I'll talk to you in the next one.